the Chief Science Officer for Pinnacle Ozone Solutions. We're here at the Guardian R&D Lab where we do our ozone demand decay studies and product development for ozone technologies. So here at the lab we are primarily focused on ozone chemistry, and the equipment that we use here are designed for us to look at the water chemical parameters that are most important for doing ozone demand decay studies, and also to look at the parameters that our clients are most interested in. A couple of pieces of equipment that we have here that are critical for our process is the TOC analyzer we have over the corner, where we measure the total organic carbon. Over here we have an ion chromatograph, and this instrument we use for looking at the bromate kinetic studies and also the formation of bromate that occurs when we do ozone for drinking water systems. In addition to that, we have areas where we can do bacteriological studies and do E. coli, total coliforms, fecal coliforms, and heterotrophic bacteria as well for dose and disinfection studies. We have, of course, traditional benchtop chemistry using a spectrophotometer for measuring key parameters like the indigo for ozone, ammonia, nitrite, nitrate, copper, iron, manganese, and so forth. Over here, we do titrations for total alkalinity, titrations for other key components like for advanced oxidation process, we use hydrogen peroxide. I do titrations for that as well to define the concentrations of the peroxide that we use for our AOP, as long with the indigo trisulfide method, as you can see here, that we have set up for doing ozone demand decay study. In addition to that, over here we have our fume hood where we do all the studies, and this is where we do liquid ozone injection and also our gas injection studies to do that ozone demand decay that is required for our clients. So over here, when we're prepared to do the disinfection studies, we have a very specialized millipore vacuum pump for doing NPN plates, countable plates for doing heterotrophic, E. coli, fecal, and total coliforms. And this is where we do all of our colorimetric detection. For ozone, as most important, we do it with the 600 nanometer visible wavelength. For us, we use a 10 centimeter cell path length for the highest level of sensitivity. This allows me to be able to do very accurate detection with using the indigo trisulfide method with this path length here, so that I can get really good detection for ozone from levels of 0.01 ppm all the way up to 120 ppm. There are other key pieces of equipment that we use at the lab as well. Of course, you have a traditional pH meter along with a TDS probe for measuring the total dissolved solids. We also do titrations for alkalinity, total alkalinity. In addition to that, we do have using a potassium permanganate solution that's a standardized normalized solution for titrating for hydrogen peroxide. This is very important for our AOP studies because we need to know the exact concentration of the hydrogen peroxide that we use for dosing into our flask, our reaction flask, when we introduce ozone and the peroxide at specific ratios.